We now invite you to sit back, relax, and enjoy today's presentation. It's my pleasure to introduce your moderator for today, Dr. Nic Williams. Dr. Williams, you have the floor.
Hey, thank you very much. That's the nicest introduction that I've ever had. Certainly every day I come to work, I'd be very fancy if I had to wait in the corridor and people said, and now I'd like to welcome into the building again, just like yesterday, Nic Williams. I think this is an awesome opportunity for everyone that's slowly ticking into the webinar, which is not, look, between you and me, whilst the organisers of this awesome event are busy organising, webinar isn't my favourite word. This is a throwdown. This is where we are going to actually get some luminaries from across the Ruby implementations to actually explain their case part by part, and I think this is going to be actually a really good opportunity for anyone who's wondered about why we have different implementations for this thing we call Ruby, and why there is actual effort being put into it, why do they exist, why you would, and more importantly, given that there are different ones, and given that they work, why you would pick one versus the other. And we could do this really boringly, I think. I think it could be really boring. I could tell you for an hour, but but I'd be biased. And this is actually what happened, because at the RailsConf, which was a month or so ago, I gave a 15-minute talk about the Ruby, so the history of Ruby, and ultimately I made a suggestion or a plea, depending on your perspective, that you should be using JRuby or Rubinius for your production Ruby. When you're running like a long-running web app, that JRuby and Rubinius are actually the better Ruby implementations that you should be using. And so that was my perspective. And my good friend and colleague, Aaron Patterson, took the floor immediately after and said, as far as I remember, he said, well, I'm on the Ruby MRI core team, so I think you should use MRI instead. And that was, I thought, unfair, that he should stand up on stage as Aaron Patterson, the exceptionally well-known, exceptionally talented and wonderful contributor to everything we have in the Ruby community, and say that. So we decided to take the opportunity to invite Aaron to talk with some people from Rubinius, from JRuby, and for us to get this sorted out. So I'm actually going to firstly show who those people are, then let Aaron and the Rubinius and JRuby presenters to introduce themselves, and we will get this underway. So today, speaking on behalf of MRI, Max's Ruby implementation, is the one and only Aaron Patterson. Aaron, say hello.
Hello, everybody. It is me.
Aaron. It's good to have you here, Aaron.
Thank you.
For JRuby, if I could say hello from Nic Williams.
Good afternoon, good evening, and good morning.
Oh, that is so international. Aaron, see, you weren't international. And, and for Rubinius, I'd like to introduce Brian Ford.
Hey, everybody, this is Brian. Glad to have you with us.
All right, so if all the listeners could, get a mental voice in their head of each one to keep track, but all the slides will be heavily annotated so you can quickly figure out who's talking at any point in time. All right, now the way we've decided to do this is to attempt to be somewhat formal, at least have the notion that we attempted to be formal, even though, depending on how this might turn into a fist fight, is we're going to have an agenda, which I think is a very old word describing an attempt to keep things under control. And basically we're going to break this up. Instead of having Aaron talk for 15 minutes, Brian and Nic then talk for 15 minutes, making a nice 45-minute thing, and we can say, yay, we did a webinar. We've decided to break this out into lots of little topics, and everyone's going to talk for a little bit about theirs. As the questions start coming in from the panelists, from the attendees, if they're good questions, I'll ask them immediately. I'll save some of them up for the end with a Q&A. So feel free for the listeners to send your questions in, and we will try and interlace those as they come in. So I want to get cracking with give everyone a chance to state who they are, give their case, and if they got spare time, why they think their home city is the best one. Aaron, kick it off.
Hi, so my name is Aaron Patterson. I work for AT&T Interactive. My title there is Webin architect. I actually architect webinars. I'm just kidding. My real title is Senior Facebook Integration Engineering Manager. And I'm going to talk a little bit about the history of MRI now. So MRI stands for Master's Ruby Interpreter. It is the canonical Ruby interpreter. It's written in C. First release was made in 1995. Most people have probably used, if you've used Ruby before, probably this is the Ruby that you've used. It is a reference implementation for all of the other Ruby interpreters. Yeah, I guess that is it. Today, the modern VM is 192 for MRI's Ruby. So I guess I will hand it off to Nic now for JRuby.
Thanks, Mike.
Yes, hi, I'm Nic Seeger. This is the sound of my voice, and I don't particularly elaborate a title as Aaron. I'm a JRuby engineer at Engineard, and I've been working on JRuby for about 6 years, since 2005 or so. And next slide, please. JRuby has actually been around since 2001, which is quite a while. As you probably have guessed, JRuby is a implementation of Ruby that runs on the JVM. The core of JRuby is written in Java, but we do have a lot of JRuby that is actually implemented in Ruby itself. So as I said, JRuby started out in 2001 as a pet project of a programmer named John Arne Peterson, and he just wanted to try to implement a different language on top of the JVM. And we've seen this happen with a number of languages, Python, JavaScript, as well as entirely new languages. And so for a long time, JRuby was just, let's see if we can actually run Ruby on the JVM. And it continued for a number of years, and it finally gathered steam as Thomas Annabo and Charles Nutter joined the project. And we managed to release the 1.0 of JRuby in 2007. Now, a couple years later, the three of us joined Engineard. We've been sponsored by them and then humbled and proud to be able to work on JRuby almost exclusively for the past couple years. So that brings us today where we have a 1.6 version of JRuby. And you can run both the 1.8 and 1.9 versions of the MRI interpreters in a single package with JRuby. And so we're going to continue to track the latest advances of MRI, as Aaron said, the reference implementation, and try to provide as high compatibility as possible. And I'll let Brian take care of his.
Thanks, Nic.
Hey.
Brian, bring it home.
Thank you, Nic. Thank you, Dr. Nic and Nic. So this is Brian. I work for Engineard full-time on Rubinius. And Rubinius is basically a completely new implementation of Ruby. Evan Phoenix started working on a virtual machine for Ruby based on stuff that he was learning about Smalltalk, and that was in 2006. At RubyConf 2006, he gave a talk about this project and announced it publicly. So just shortly after that, in December of 2006, I heard about the project and started contributing, initially writing a lot of what eventually became the Ruby Spec project that's used by all the implementations now to measure compatibility and compliance with the what Aaron mentioned as the gold standard MRI. In 2007, Engineard hired Evan to work full-time on Rubinius, and Engineard has been a really generous sponsor of the project since then. So we're really proud to work here with Engineard. And we've also had hundreds of people who have contributed to the project. We have hundreds of people on our committer list. So it's a pretty interesting project. Now, to give you a little bit of details about it, just a brief overview. Basically, we have a custom virtual machine that was built specifically for running Ruby code. It's got a modern generational garbage collector and a just-in-time compiler that will convert Ruby code to native machine code so that Ruby can run really fast. One of the goals of Rubinius also is to write as much as we possibly can in Ruby, so the entire core library, things like your familiar classes of array, hash, string, range, etc., those are written almost entirely in Ruby. And it's a big point of Rubinius. It's one of the goals that we have. We want to make it possible to write more in Ruby and less in C or other languages. So right now we support the 1.8.7 version of Ruby, and we have we're working very hard on the 1.9 stuff that's coming in Rubinius 2.0. We have a developer preview out for Rubinius 2.0, so you can kind of track us on that, and I'll have more to say about that later.
So Brian or Nick and Aaron, so Brian's saying that most of the core libraries are written in Ruby. Does that mean, like in JRuby, most array is written in Java, or is that what's the distinction there?
So this is Nick. That's true that the array core libraries in JRuby are written in Java, but that doesn't mean you have to write exclusively in Java. Java can just be thought of as a layered. Java is to JRuby as C is to Ruby as C++ is to Rubinius. In the general sense, it's a lower level layer that we drop to for speed.
So an array behaves like a JRuby array behaves like a Java array or like a Ruby array?
Oh, no, it's most certainly the Ruby array that we all know and love.
Gotcha. All right, gentlemen, thank you very much for that introduction. The next most interesting thing, I think, is to figure out, as a comparison state, the ecosystem that surrounds, these implementations. Obviously, it's libraries are pretty useless, languages are pretty useless on their own, and the interesting part is figuring out how you use it to integrate with the rest of the world. So what I want to do is kick off with Aaron. Aaron, the gold standard. What's the ecosystem?
Yes, the gold standard is MRI. So pretty much since it was the first, most of the gems on rubygems.org can be used with MRI. So, any third-party libraries on rubygems.org can be used. And since MRI was written in C, we can access any C-based languages from MRI. So C or C++, any kind of derivative of C languages, so even Objective-C wrappers. And interestingly, MRI ships with wrappers for some C libraries like libffi, libyaml, and OpenSSL, and other gems distributed on rubygems.org bridge the gap for other C-based libraries. So pretty much from Ruby, you can access any sort of C-type language that you want to, in addition to all Ruby code that's available. So that's pretty much the MRI library ecosystem. And I will pass off to JRuby.
Right, so JRuby, of course, is in an interesting position because we're implemented on a JVM, and we also provide facilities to easily access any Java class or library. So you can certainly use JRuby as a drop-in replacement for Ruby, but you can also use it to access Java code or any other code that runs on the JVM. We do actually have a C extension compatibility layer in JRuby 1.6. I put an asterisk next to it because we still consider it somewhat experimental and more of a migration aid than as a tool to run production code. Of course, the JVM has its own kind of idea of memory management, and to allow arbitrary C extensions to come in and co-opt the JVM process is possibly a little dangerous, so we don't suggest trying it. But as I said, you can access Java seamlessly, and you can, from Ruby, you don't actually have to write any Java code to do that. And as a result, a lot of popular Java libraries that are rock solid, things like Lucene for document indexing and searching, have sprung up little wrapper gems around them, where you basically write pure Ruby code and create a nice Ruby API around the Java classes, and you can package them up as a gem and release them to rubygems.org. And these, of course, are JRuby-specific gems, but they give you a nice, easy way to work with existing Java code or legacy Java code. So as I said, sorry.
Are there any big successes with the C extension layer, or well-known things that just will never work through the C extension layer?
Are there there are a couple
since you released it
off my head. There are things like I think, as Brian will tell you, there are a couple of C extensions that do things that are very specific to MRI's internal layout that we probably won't be able to support on JRuby. And I think there are a couple of other things like, I want to say that we have the thin web server that actually does compile and run, but it's not, those kinds of larger gems are going to still be problematic. And we generally take it's hard to decide whether to try to build the C extension layer better or to just say, well, let's provide a different option in that case. So it's kind of
Nick,
either or.
This is Aaron. I was going to say I've actually run SQLite with JRuby, the C extension. So there's one.
Okay, we have it.
Thank you very much, Aaron, for providing that example.
You're welcome.
Brian, what do you got? We've lost Brian. Brian! All right, until we find Brian, I'll read his slide for him. So the Rubinius ecosystem is aimed at being identical to MRI. Basically, anything you can use in the MRI world. I mean, Rubinius' goal is to be a drop-in replacement for MRI. So the C extensions and GEMS work. There's and obviously there's a page Rubinius projects where you can sort of start to see some of these. But what's also part of their ecosystem is that people are starting to implement alternate languages. So treating Ruby as one example of how to use the Rubinius VM and the Rubinius infrastructure to implement a language, and there's a number of other projects underway for implementing different languages. So that's an interesting extension of what is the Rubinius project. Now, hang on for a second. We lost Brian. Brian, are you there?
I am. Can you hear me?
I can. So, Brian, did I do a good job talking about your slide?
I heard just the last little bit. It sounded pretty good. Yeah, I would just emphasize that basically the other languages thing is very interesting. It's a great way to integrate with languages in a very consistent manner, somewhat like JRuby does with the languages across the JVM. So it's sort of a platform. The other thing that I would emphasize is that you can basically, the goal of Rubinius is to drop Rubinius in right now where you are using MRI. So most people are really familiar with MRI. They're familiar with it in a development environment and a deployment environment. And with Rubinius, you don't have to change anything. You should be able to, for instance, if you're using RVM, simply RVM install RBX, RVM use RBX, and then just start up your Rails application or other application and go with that.
So Rubinius, is it a bug in Rubinius as an example of a statement of intent? If a C extension gem doesn't work for Rubinius, is that a bug in the gem or a bug in Rubinius?
It depends on the situation, of course. There are, like Nic pointed out, there are some C extensions that actually try to use the object layout that's in MRI, and we can't support that. We do support it a bit with string and array because there are common macros that you use in a C extension to iterate over a string or array, and we do support that. However,
so what's the preferred way for gems to be written as C extensions?
For gems to be written as C extensions, the preferred way is to use functions rather than trying to access the data directly. So that's just good portability in C coding in general. You never want to poke into somebody else's memory. That's rude to do. And so if you're behaving respectfully and you use a function interface to data, or you call a function, you pass in the data, and you let that function return you a value, that will work really well. And we've found the reports from users that most common C extensions work just fine. And if you encounter a C extension that doesn't, the first thing to do would be to come chat with us or open a ticket, and we'll take a look and let you know whether or not we can support it. A lot of times it's just maybe a C function that we haven't implemented yet.
Okay, so basically tickets should start with the Rubinius project and then push back down to the root project if it's...
That's the best way, sure.
All right, fantastic. All right, I think one of the most interesting aspects all the topics we've got here are interesting. One of the things that certainly is of interest to me, damn it, all the items here, concurrency, Windows, and deployment are all interesting. The next most interesting is tooling, which is the scope of, given if you're in JRuby, if you're in MRI, what are the set of tools that you can use to make your life as a developer and your life as in production better. So we'll kick this off on this occasion with the JRuby, which sits on the JVM.
Thanks. So when people think about the JVM and they think about Java, if you're unfamiliar with that platform, it might seem a little bit daunting at first, or it might even seem something unsavory. But in fact, I want to emphasize again, you can use JRuby without having to know the internals of the JVM or even the configuration flags of the JVM. JRuby does take care of that for you up front. But if you want to take full advantage of the platform, you really want to start to learn a little bit about the JVM, and there are a number of things in there that are built in that you can also use to inspect your JRuby processes. The one thing I want to point about the JVM is that it's a piece of software that's been in development for 15 years by hundreds of engineers, and it's been running many businesses successfully and keeping them up for a long time. And so the number of engineering hours put into this platform is really dwarfs just about any other piece of software out there today, other than low-level systems, obviously. So one of the things that comes with that platform is the idea that things stay up all the time. It keeps track of memory for you. It keeps your process from leaking memory and taking over your whole system. And that's something that is a little bit different from the MassRuby, where MassRuby will continue to use memory unbounded unless you have some sort of a process watcher. You don't need that with the JVM. Another area that the JVM shines is with tools for monitoring and debugging and profiling. And this is a screenshot of a program called Visual VM that ships with the JVM, and it gives you a whole dashboard for monitoring the CPU, memory usage, class usage, thread usage, and there are even plugins for this program that you can use to do profiling and debugging inside. There's also the fact that the JVM integrates with a number of IDEs. You can do stepwise debugging in both Ruby and Java code inside of the IDE, of course, if you're used to those environments.
Nic, I remember Charles Nutter doing a demo video or blog post about this before. Is that somewhere easy to find?
Is it somewhere easy to find? We're going to be having a follow-up JRuby specific webinar here, and I'll make sure to have that information close by, or we may even find that it's time to update that blog post and get it current, and we'll feature it front and center.
All right, fantastic. Brian, what do you got? What tools?
So in Rubinius, we have one of the things that we're really interested in doing, and we're beginning to work on, is tooling. It's really important, right? We want to make it possible for Rubinius to write really good code, write it faster, and get it working. So we provide a built-in profiler and debugger. So you can just invoke Rubinius and profile your code and get an idea exactly where the code might be slow. There's a Ruby API to that, so you basically can also script that from Ruby. We also have a debugger built in, and that debugger runs very fast. Only the method where you set a breakpoint is running under what's called the debugger interpreter. So the rest of your code is running really fast. If you're deep into Rails, a lot of people report that it's difficult debugging that because you have to wait around for stuff to happen for quite a while. With Rubinius, that should be really fast. Evan reports debugging a lot of stuff in Rails deep in there, and it's quite easy to do. We don't have a great amount of docs on this right now, but we are improving the documentation. One of our contributors actually wrote a fantastic document on doing memory analysis to find an object leak that was related to a C extension that he was using. So this tool is a pretty interesting one. I've actually worked with people that have been tracking down object leaks in Rails and other applications. So it basically allows you to dump memory and compare a dump from before you run some code and after you run some code and see what the difference is and see which objects you might be leaking there. Finally, we have something called we're calling it an agent, the Rubinius agent, and it allows you to monitor and control a Rubinius virtual machine locally or remotely. So you could potentially have a bunch of virtual machines running up on servers somewhere, and you can have a dashboard locally that is tracking their health, things like how many threads they have running and how much memory. And so we're gonna work on putting a graphical interface on top of that. So that's just sort of an overview, and we'll delve into that more in the Rubinius follow-up webinar as well.
Okay, a quick question. Is it the Rubinius debugger and these tools, is that what Evan Phoenix did a bunch of improvements to some speed aspects of Ruby gems? Was he using the Rubinius tools, or how was he doing that? Yeah,
Evan... Basically, that's sort of the thing, right? We're writing in Ruby, we experience the pain, and then we try to fix that pain. So Evan has worked on Ruby gems, and he's delved into bugs in Rails before. And from that work, he's done the work on the Rubinius debugger. And there's more to be done, but there is another, the Ruby debug project has sort of spun off into something called trepanning, and there's a specific RBX trepanning which uses our debug API and then implements a nice command line interface around that. So,
okay, sure. Will one day you ever get a shiny thing like this?
Like Visual VM, absolutely. I'm actually doing a talk at RubyConf coming up about a tool very much like that.
Because obviously this is quite pretty. All right.
That's fancy.
Oh, it was fancy. Aaron, what do you got?
Yes,
Mr.
MRI
He who loves to optimize things.
Yes, I love to optimize things, and so I'm going to talk a little bit about the tools that I use for optimizing code when I'm dealing with MRI. So typically, when I need to do performance analysis, I'll use a tool called Perf Tools. Oh, and I want to mention that most of the tools for profiling MRI's code are based around C-type profiling tools. For example, PerfTools.RB is built on top of Google's Perf Tools. It's just modified so that we can get diagrams of Ruby call traces. Obviously, we can use GDB, but if we don't want to go that low level, Ruby comes with a GDB-style debugger. We can also use dtrace, but that only comes on OS X Ruby. However, we decided at RubyKaigi we're going to include dtrace probes natively in 194, so you can look for that. Also, there is a GC profiler built into Ruby, and I use that for counting memory size usage, and we can look at.
I think we got some examples of that.
Yes. So
all right.
On to the example. So this is. Please don't read this. This is just kind of what our.
Now, let me just quickly go through this for people. The bottom really small one says. Actually, even on my printout, I can't read it. It says initialization. These
are probably some profiles I took while doing Rails performance improvements. But basically, you get with PerfTools.RB, you get a graph that looks like this, and you can see how much time you're spending in a particular method, and how much time you're spending in those methods' children, etc. And next slide.
Sorry.
Thank you. So when you're using the GC profiler, this is the kind of information you can get, like number of times the garbage collector was called, amount of bytes used in memory, total number of objects, amount of time spent inside the garbage collector itself, etc. And next slide. So when we're using object space, we can actually count the number of objects that are alive in the system. So sometimes when I need to know, I need to measure the number of objects that are created for a particular function call or whatever, I can use object space. And those are most of the tools that I use for debugging MRI stuff. So check out Perf Tools.
Is in the context of, given that you're debugging Ruby code rather than the Ruby running code, not the Ruby dev code itself, the tools, just from your perspective, as someone who uses a lot of these, are the tools that Rubinius JRuby, or are any of the problems you solve, theoretically, if you use these tools, would they be solved faster, better, give you a different perspective?
Well, I think the tools that are provided in JRuby and Rubinius, I can get most of the same information. It's just that I think some of them look a little prettier. For example, the Java ones look a little bit prettier than the ones I have. So, I think I can get about the same information. It just depends on how you look at it.
Okay. Now, we thought we were amusing ourselves, and although the slides don't tragically share the amusement, we thought we'd attempt to do the following section in parallel. So, everyone, all together now. Let's do it. Let everyone hear the C. La. All right, let's go. No. All right, Aaron. No doubt you have the far superior concurrency solution like everyone else. So give it to me. What do you got?
We're all presenting our concurrency solutions at the same time, right?
That's right.
Wouldn't that be cool if the slides actually did that? Unfortunately, we came up with that joke like 5 minutes ago.
Yes. Oh, yes, you did. But I said it. Oh, I have to say it. Hello, Santiago. Anyway, MRI and concurrency. So,
anyone else want to, quick hello to family back home, people in South American countries? That's right.
MRI and concurrency. We have, so in Ruby 1.8, we had threads in Ruby 1.8, but they were all green threads. So it meant that they're not actually implemented in native threads, but rather inside the Ruby virtual machine itself.
So Ruby 1.8 only uses one process on your machine. One CPU. In 1.9 we actually have native threads, but the problem is that we have a global interpreter lock in 1.9, so it's actually difficult to get code to run simultaneously. We can run code simultaneously.
Like, I'm still a bit of a noob when it comes to this. So what does it mean to have threads but not have threads?
What does it mean to have threads but not have threads?
You have threads, but you've got this guild. So what does that actually mean? What level of concurrency do you get in a standard Rails app?
So basically, you can run code concurrently, but only if you request it down at the C library or the C level. So it's I think Brian said it better than I did the other day. It's that it's when you can run Ruby code or not. Is that right, Brian? I think you said this.
That's basically right, yeah. So the global interpreter lock means that whatever is interpreting Ruby has a lock around it. So there's a single thread that can run Ruby code at one time.
Okay, so one line of Ruby code can be run at a time, but not two.
Right.
The concurrency happens outside of Ruby.
Right, but we can do wrappers around certain blocking functions, so we can say, like, well, when we're reading off of when we're reading off of a socket or whatever, then I'm going to release the GIL and go execute something else. So in some cases, we can actually do real concurrency.
Yep.
So the other solution for concurrency is we have fibers, so we can do coroutine processing, and other solutions that people use for concurrency in MRI are via evented I/O. With things like Event Machine.
And then Ilya Grigorich came up with a shiny combination of the both with his EM Synchrony.
Exactly, yeah.
All right. Brian, do all 5 points at the same time.
Okay, I will do them all at once. Threads, native threads, fully concurrent native threads, native fibers, event machine actors. So that's the overview. We started out with green threads way back when, and right now in master, the current release 1.2.4, we do have native threads. They do run with a GIL exactly like MRI 1.9. We do have a very good I/O layer, so you can potentially get good concurrency even with the GIL. However, the point of writing Ruby code and running Ruby code means that we want that performance in Ruby. So in Rubinius 2.0, the GIL has been removed, and so far the concurrency looks really good. So please try your applications. If they use 1.8, you get all that goodness in 1.8, all the full concurrency. We also have native fibers. They don't use threads in the background. They manipulate the stack directly, so they should be fast. We can certainly support the Event Machine C extension. That works well. And we're really interested in other concurrency mechanisms. So way back in 2007, a contributor, actually renowned Rubyist mental guy, wrote our actor implementation. And the actor model is basically how Erlang works. So if you've heard about that, it's a very interesting way to think about doing concurrency, and it doesn't suffer from many of the problems that you get with shared update or concurrent update of shared data structures like you can have with threads. But actors are available. Actually, you can use them. The Rubinius actors you can use in JRuby now because it's just sort of a Ruby library, and they implemented the one primitive that we use called a channel. And another contributor, or not contributor, but another guy, Mike Prum, wrote a interesting background processing library called Girl Friday. You can check that out. It uses actors to implement background processing.
Well, I think he's going to be talking at RubyConf about that.
Awesome.
All right, Nicholas.
Yes, so the main point that lets JRuby stand out when it comes to the concurrency story is that JRuby was the first implementation to have fully native concurrent threads, and we've actually done that from day one. I guess you could say it was sort of a lazy design decision to just say, well, we need to implement the Ruby thread class. Let's just map it directly on top of Java's native threads. So as a consequence, you can have concurrently running Ruby code. That does have some unexpected results we'll talk about here. So if you look at that, well, I'll get to that example in a second. I'll just mention briefly that JRuby does have 1.9 fibers. They're backed by threads, as Brian pointed out. We don't have a coroutine facility in the JVM, although there may be one in the future that we can use. The other ways you would do concurrency with JRuby would be to take advantage of numerous libraries, Java libraries, that allow you to do kind of common patterns for threading and for other methods of concurrency, including actors and things like STM, software transactional memory, things like that can be done simply by accessing the Java libraries and implement those features. So back to this code example, just to point out that the consequence of fully concurrent code is that you may have some data corruption. Now this code, when you run it on standard Ruby with the GIL, you get, as a result of the code, you get a data array that is m times n, and it has a full set of integers in it. The order may be a little bit different, but it's still a well-formed data structure. Now, if you run this in JRuby, you get all the code in the thread block. It's run concurrently, and you end up with a sort of a corrupted data structure. It might not be n times n. It may have some nil entries. So there's some consequences to think about when you run Ruby code alongside each other in JRuby.
Yeah, so some of the Ruby libraries have never been written, or does Matt actually have a goal of making some of these core libraries thread safe, or are they left to the implementer to do that properly?
Yeah, I think Matt is kind of agnostic on this subject. He's sort of blessed our approach here to say that the core Ruby libraries are not intended to be thread safe. They kind of behave that way because as a consequence of green threading, but it allows us to implement the core containers and objects as not thread safe. So you can get the advantage of running concurrent code. You don't have to take the hit of running things synchronously, but it does have that downside. You have to be a little more careful.
The next interesting topic, certainly to my heart, and ever since I came to Ruby on a Windows machine, I know thousands and tens of thousands, hundreds of thousands of people have come to Ruby via Windows, and if you follow some of their life paths, yes, some of them move off Windows and purchase other vendors' machines, but certainly of interest to me and to many people as to what's the level of support for Ruby in the Windows world. So I want to start with Rubinius. Where are you guys? What's the status on where you guys going?
So the short story is simply that Windows support is coming in Rubinius 2.0. We are working really hard on it. It will support 187 and 192 and have full concurrency and C extension support. We hope to utilize our build system to make some of the C extension pain on Windows a little bit less painful. We'll have a native installer. We're really happy to support Windows as a platform. Most of the reason that we haven't supported it yet is that none of us that have been working on Rubinius are core, sort of Windows developers. So please help us out. We've got the build system to the point where Rubinius is building, and lately some contributors have been stepping up and working on that with us. So when Rubinius 2.0 comes out, we'll have Windows support.
Fantastic. And Aaron.
Yes. So MRI and Windows, we don't ship MRI unless it runs on Windows. That is our Windows story. But besides that, there are projects like Ruby Installer in order to get it actually installed on your system. So you can go check that out. And also Rails Installer, which I think is sponsored by Engineer. Is that true, Nick?
Yep.
Rails Installer? Yeah.
I mean, we started it, but obviously lots of people help with it.
Yep, absolutely. But if you want to get Rails and Ruby up and running on your Windows system, you can go get Rails Installer. There's a caveat that some C-based gems may not work on Windows, and the reason is because when gem authors write their gems in C, they either need to ship binary gems for Windows, or Windows users must install the development tools. Typically, I ship binary gems for my C-based gems so that Windows users can just install the C-based gem and not have to think about it. But if the gem author has not done that, then as a Windows user, you might need to install the dev kit along with any libraries you might need.
with the Rails install, I think the dev kit was added by default just to smooth out that experience, because we don't really want anyone to have to discover that. It's like, why does this gem not work? Well, please go to this page.
Yeah, you forgot these other tools.
Well, you can't go too far before you need to install a C-based extension, because Ruby obviously is a big fan of them. So, and Nick.
Yeah, so JRuby on Windows has a pretty good story. It really just works, and it's worked from day one, primarily because most of the way we interact with the operating system is through the JVM, and the JVM already has proven and pretty dependable cross-platform support. So we also have an installer for JRuby. For those of you who are unfamiliar with the JVM or may not have it on your Windows system, we have a couple flavors of installers with or without the JVM bundled, and 32 or 64-bit versions. We also have an interesting distinction with Windows that we're currently, as far as I know, the only version of Ruby that will handle 64-bit Win32 OLE applications. So if you're doing any kind of scripting of the Windows API on a 64-bit Windows system, JRuby is going to be the way to go there.
Yeah, we discovered that with the Vagrant project, which runs on top of VirtualBox, and VirtualBox being 64-bit. Therefore, you have to run the current solution for Vagrant is you have to run it on JRuby, 64-bit JRuby, so that you can actually use VirtualBox.
That's correct. And then finally, our Windows support continues to be strong because we actually have a Windows build running in CI, so that pretty much every check-in runs our full test suite on a Windows system.
How do you do that? Is that with the tests are run on a Windows machine somewhere in the magical places of the cloud?
Yep.
Did I just answer the question by asking it also? That was a very good question. I could have just said, I could have asked how. That would have been more open. All right, the last of the topics is deployment. And what I want to do is to start with, bring this home with the MRI. The gold standard, the self-professed gold standard. How are we deploying there?
So I'm just going to talk about the tools that we use at work for deploying our applications, because we deploy all of our applications on MRI. Typically, we use, for our production machines, in order to get Ruby onto them, we'll use apt or RPM or dpackage, depending on the target system. And in order to get our Rails applications onto our remote systems, we'll either use Capistrano or Vlad. And then the web servers we use, Unicorn, Nginx, etc., but pretty much anything will run on MRI. So,
and WebRick.
Yes, and WebRick, which is an awesome web server because it is threaded. So, yes.
Brian?
Well, basically, Rubinius, again, the story is essentially identical to MRI. With the added advantage that you do have full concurrency in Rubinius 2.0. The common, web servers, Passenger is sort of a big thing right now. Unicorn and Rainbows are also options because they use thread-level concurrency versus process-level concurrency, but Rubinius works just fine with your typical POSIX environment. So if you need to fork, that works. We are really excited about WebRick. There may or may not be, I can't confirm or deny whether there is a secret project going to refactor WebRick a bit and speed it up. But WebRick is pure Ruby code. It does handle threading well. So it would be a fascinating thing if someone wanted to experiment running their application with multiple threads under WebRick and see if we couldn't actually beat one of these C web application servers that are running with only one thread. So basic idea is that Rubinius is much like MRI. Take it away, Nic Williams.
Right. So in JRuby, the deployment scenario is kind of enlarged by virtue of the fact that we're kind of exposed to a Java environment. So you can do a familiar directory or file-based deployments with the Ruby server, again using WebRick. JRuby also has a couple of custom servers just for the JRuby world to do that sort of thing. So we don't, the popular servers like Passenger or Unicorn do not work on JRuby. So we have our own, we have a server called Trinidad, which is basically JRuby plus Tomcat, and that will run in pretty much identical fashion to your familiar Ruby servers. In addition to this, you can also bundle up your applications into a WAR file and deploy Java style into a Java container. That's certainly an option that works well for a lot of people, and it brings the whole world of Ruby into the Java enterprise world. And then finally, of course, we can enjoy deploying JRuby to Engineer at App Cloud, which is currently in beta. And you can also deploy JRuby to Google App Engine or to Amazon's Elastic Beanstalk. Next slide. So again, I wrote a blog post a while back that talks about the JRuby specific servers. You can check that out. Next slide, please. After a moment. Yep. Oh, and okay. And so getting back to the distributing your application as a WAR file or as an executable jar, the Warbler project that I work on. Next slide, please.
So the next slide mechanism here is awkward. I apologize.
No, that's fine. So the idea with Warbler is you can create an executable WAR file or jar file, and you run it inside of your application, and then you just start it with the normal Java -jar mechanism, and a web server will start it for you. So that's a nice way to build a small web application, put it in a single file, and you can move it around to any machine that has a JVM on it.
And Nick, if you're in a business that already has a Java-based, production environment, you can just hand over the WAR file, and your local Java sysadmin will know what to do with it.
Absolutely. Thanks for setting me up again for an easy confirmation.
It's nice having you all here. Obviously, I could do this. No. Now, we actually have a couple of questions that have come in through the thing. If all the listeners, there's hundreds of them, which is so fantastic. Any more questions? Hopefully, I'll ask them without giving yes/no answers implicitly. But I'm going to kick off with a couple whilst the rest of the questions come through, and hopefully we have some time. I've got a few follow-up things. So, from Chuck, what kinds of changes would we need to make to the C API 2.0 to provide safer C extension support, native thread support, and maximize performance across all the runtimes? So perhaps that's a question ultimately aimed at Aaron.
So I think I can answer that. To be honest, I think probably the best thing to do would be to follow the C extension support that Rubinius offers. So since they're using a compacting generational garbage collector, that would give us their C API would give us the most flexibility. So I think if we could follow their C API in the future, that would be best.
Is there going to be a way for Ruby to change its C API, or is it going to have to support backwards compatibility, or is Matt going to say, let's break all C extensions when we go to 2.0?
To be honest, I don't know. I was actually talking to at RubyKaigi. I was talking to the current implementer, or the implementer of the current garbage collector, talking to him about getting a generational compacting garbage collector. He said today he thinks it's possible to do generational, but not compacting because we can't move C pointers. But on the other hand, if you do a compacting one, that means that you have to keep a map of pointers to real objects. So possibly that could have performance impacts, he thought. So I don't actually know. It's tough to say what's going to happen.
Sorry, go.
So let me just add a couple of things to that. Let me clarify first that Rubinius C API is just the MRI C API right now. We have to do things behind the scenes to make it work with our garbage collector, but those are the things that Aaron pointed out that we would like to avoid. Namely, we have to keep a reference from the object to the pointer that we hand out to the C extension. So to produce a better C extension API, what we need to do is essentially change some of the C APIs so that when a C library is holding on to an object reference, so it's holding on to a Ruby object, it can't pretend like that Ruby object is always going to be at the exact same memory location. That's going to require some fairly deep changes to some of the C extensions. So it may not be possible to support all C extensions going forward. However, what Rubinius has demonstrated is that it's possible to support a fully generational garbage collector that does move the locations of objects without breaking common C extensions. So we could actually have a transitional phase where we take and support, like Rubinius does now, existing C extensions, and hopefully work on a new API that would probably be modeled much like JNI under the JVM that explains very clearly how C and C++ and Fortran and other code has to treat object references. And that would be something that we could support very well across JRuby, MRI, Rubinius, possibly IronRuby as well.
Cool. All right, there's a couple of questions here that are debugger related, and I'll try to make them a bit more generic, but will Rubinius debugger, I guess, JRuby, and be compatible, or is there a way of making them compatible with the Ruby debug IDE, RubyMine, et cetera, that some of the tools are starting to build around the MRI's debugging story, or is it going to be independent?
So this is Brian again. I think that it's certainly possible to do that. There are definitely debugger APIs. The JVM has a particular debugger API, and in Rubinius, we implement the underlying low-level stuff and provide a Ruby API on top of that. If there are places where we don't support some functionality that's essential, we could certainly add that support. So it'd be great to see a single high-level API that a GUI uses, right, in your IDE that could support all of the Ruby's running essentially down below.
And what about JRuby?
Well, so JRuby already supports, right? JRuby already has a specific implementation of Ruby debug that allows the Ruby debug IDE stuff to work.
Okay.
So there is really about, can we find a way to integrate the Java side with the Ruby side a bit better, and that's still sort of out in the future.
I've got 100
on that problem themselves, but it'd be nice if we had a standard way to do that, where you could step from Ruby to Java code from a unified debugger that's accessible to everybody and not just a particular IDE.
We've actually got dozens of questions in the last 5 minutes, and there's, unfortunately, that's way more than I'm ever going to get to answer. We might figure out if there's a way for us to get answers and put them up on the web. I think one question here that I actually was thinking of asking earlier, which is, verbatim it says, interesting, no one talked much about FFI when dealing with C extensions. What do people think about FFI?
So FFI is a great tool. Rubinius, actually being fascinated with writing Ruby code, actually wrote the initial FFI implementation, and then JRuby contributor made a version of that works with JRuby and MRI. So it's something that's available across all the Rubies. However, as something that allows you to connect to native code, it can be good or it can have performance implications. The really good use for FFI is when you have a library and you call out to some function and it returns you a value. We use FFI in Rubinius to bind Ruby to all of the normal POSIX stuff that is going on under the covers. So we find it very useful. It's an integral part of Rubinius, but there are cases where a C extension will be better because you have to do a lot of work in C, and if you have to call out, get a value back, change it, call out, get a value back, change it, those sort of things, that could be slower in FFI. But FFI, you're right.
Is FFI the same across all of them? Like if I write an FFI C extension, does it work in all the different current implementations?
The API has diverged slightly from Rubinius's original API. However, in Rubinius 2.0, we're working to get that back to the same so that it's the same across every Ruby implementation.
Is that because it went off as a separate gem and they developed it independently?
Right, it kind of diverged a bit, but again, it's most of the core functionality is there. And if you are running an FFI, if you have an FFI-based library and you're experiencing trouble in Rubinius, just open a ticket.
All right.
We'll fix it.
The last question before we do some summaries and a couple of final bits and pieces is, I think, really the best, fieriest question to ask. For a typical Rails app, and as I finish this question, first in, can lead the answers. But for a typical Rails app, which of these is the fastest and most stable option?
Define typical Rails app.
MRI, absolutely.
JRuby, totally.
Yeah, we've had reports that in Rubinius, the memory use and the memory profile over time is really much more stable in Rubinius. So we find that's interesting. With the JIT compiler, we can obviously accelerate Ruby code quite a bit. So we would love, it's a great question, and we would love to have that typical Rails app so that we can understand Rails performance better. So if someone has that typical Rails app, if they could please submit that, in a GitHub repository and let us know, we'd be thrilled.
So you're suggesting there's not a typical Rails app, but the typical Rails app. We need to, as a community, decide what that is.
Is there a typical Rails app?
That's right. Oh dear. But no, I mean, stable is interesting from various perspectives. And I remember hearing Evan do a talk at a conference, and he said, something along the lines of, you make as many objects as you like, we've got you covered. There's this notion of, don't worry about, not that many Ruby people would worry about it, but, there's memory bloat is an interesting aspect of stability. Are there actually, reports of for production one being substantially faster than the other, JRuby versus MRI 1.9.2?
I have to say, sorry, go ahead.
I was going to say, well, for JRuby, we have a little bit less data than we have with MRI. I mean, of course, MRI has been the primary production choice for a long time, and JRuby is in beta now in Engineered's App Cloud, and we've talked to JRuby users over the months and years, and we've gotten selective reports of good performance. But the thing is, there's always a migration issue between one and another because they don't quite work the same. So it's really a matter of what tool fits your use the best. And I think JRuby running on the JVM does have a potentially good story for running code fast. It really depends on the application. Go ahead, Aaron.
Oh, yeah, I was going to say, it depends on the application, and really at work we've been very happy with the performance of MRI in production, so happy that we haven't had a reason to change, really, so.
All right. Now, just a follow-up question from Charlie. He's obviously on the line listening. Clarification on FFI versus C extensions. At least for JRuby, FFI is a lot faster. I assume he means a lot faster because it doesn't have to manage handles, pointers like C extensions, JRuby or Rubinius. Now, that's a lot. There's a whole bunch of questions, and we're going to try and find a way to process those in an interesting fashion because some of them are specific to one language or another. So what I want to do now is to give everyone a chance to summarize, to state their case for the people who've been scratching their heads. Aaron?
Yes, top reasons you should use MRI. It is canonical. It is the reference implementation. It defines how all of the other implementations work. There's a large ecosystem around it. It is fast and fun to play with. And most importantly, if you're using OS 10, you don't have to do anything to install it. It is just there.
What about the new OS 10?
It is still just there. Unfortunately, it's 1.8.7, which is lame. I don't know why they did that, but whatever.
Brian?
Yeah, so there's a lot of fascinating stuff in Rubinius, and we are working really hard to provide this Ruby option that fits right into the development and deployment environment that people are familiar with. And you can use Rubinius today. It supports 1.8.7, and we are working really hard. The 1.9 support is progressing really well. There's a lot of modern technology in it, including the garbage collector, which, again, we've found that it handles the memory profile much better over time. We're also working really hard to make Ruby sort of a first-class language where you write your libraries and applications in pure Ruby without having to deal with the additional complexity of interfacing with a foreign language or a language that folks may not be familiar with. And as we're focused on that Ruby, we're focused on supporting new and better tools to help Rubyists write fast, easy to maintain, world-class Ruby applications. And Rubinius is available, I believe, in beta or at the edge of beta or something like that. It's certainly available on the Engineered App Cloud. If you're an Engineered customer, request access and give us feedback. Help us know how it's working for you.
Fantastic. And Nic?
Next slide, please. Yeah, so really JRuby shines when you want to use Java and Ruby together or any part of the JVM and Ruby together. So you can certainly access Scala code or Clojure code, and you can experiment with those new and up-and-coming languages as well. Again, I'll stress the maturity of the platform. Brian mentioned modern technology. Well, the JVM has really been the poster child for modern virtual machine technology. So that's certainly another reason to use JRuby. And then everything that comes along with that, performance, stability, concurrency, all the things that we've talked about today. The JVM continues to advance at a rapid pace. The Java 7 is coming out at the end of this month, I believe. And we've had reports that simply by upgrading from Java 6 to Java 7 and changing nothing else in your code base, we've seen like a 10% performance improvement. So those kinds of things are the types of things you get with JRuby and JVM.
Fantastic. Now, for people, we are slightly over time. We've got a couple more interesting things for people who've got to this point. When you sign off, there's going to be a survey. We'd love it if you could fill in the survey. There's a couple of real quick questions about what you saw, what was relevant, because obviously we want to be able to do more of interesting, relevant things, and not just whatever Dr. Nic thinks is interesting and relevant, which could very quickly extend to interesting ways to look after children on a weekend. So we have to be careful not to let me be in charge. So the survey is there to help us give you what you want. Now, a couple of last interesting things. Obviously, the reason we care about all these Ruby implementations is for the longest time we've had AppCloud and we run all of them. So the stack is what you get as part of the broader product. And as everyone mentioned, you can get yourself a free Engineered account, put your application, try it on JRuby, try it on Rubinius, try it on the different MRIs, including RAE, and find out which one is the better place for you to be running your app. Obviously we're not there. You're not going to be the first and only customer that we've had. Thousands of customers, many of them with very pretty logos. And a couple of things coming up. The JRuby Conf is just weeks away down in Washington, D.C., which is home of so many important American things. And I don't know what they are, never having done American history, but Washington, D.C., JRuby Conf, meant for each other. Sign up, go, really cheap. Going to be a great conference. Coming up in just a week or so is the first ever Rubinius Day, where Global Day, we want you to test Rubinius if you haven't already. Play with it, see that it works just the way you want, and just have a great time enjoying the fact that this is a Ruby built in Ruby for Rubyists. A couple of times I think guys mentioned that we actually did a follow-up. Obviously we only had an hour here. We wanted to talk about everything in as broad a detail as possible. 18th of August for Rubinius, 25th of August for JRuby, and so a lot of the questions that were asked that I didn't get a chance to put forward, going to get a chance to answer those on that day. I want to thank everyone who's been on this. We had hundreds and hundreds and hundreds of people listening to this call. I want to thank Aaron Patterson for coming in from, he's sitting in his house, but for spending the time, not just today, but we had a couple of practice runs. He was there. He's been a wonderful person to work with, Aaron. Thank you very much for that and for everything you do with MRI.
I am
Brian Ford. Thank you very much. Brian Ford, thanks again for participating, for all the work you're doing on for Rubinius.
Thank you, Dr. Nic, and thanks for everybody who came to join us.
And Nic Seeger, the JRuby stuff and the bits and pieces that you've done around the edges of JRuby, the core work, and also your participation has been wonderful. So thank you very much.
Yeah, thank you. I'll just echo everyone else's gratitude. This has been fun.
So thank you very much to listeners. I hope this has been incredible. Certainly, I'm lucky. I got to ask questions as we went along. If you have more questions, put them in the Q&A and we'll try and get them answered. If not directly, then later on, or to put them on Twitter on the mailing list. And hopefully this has been helpful for you to be able to pick the Ruby for your life.